All right, so let's take a look at the very last one in section 1.4 here. So we had talked about already how this is in indeterminate type of form, right? 0 over 0. And so we got to do something clever with this. We can't, plugging it in didn't work. So we got to be a little bit smarter. Now, one thing that we could try is using like a double angle formula and splitting up sine or the sum of two angles within a sine or tangent function, right? We could do all of that stuff. But yeah, those get a little bit messy. They do work sometimes, but also most of us don't have those on recall. However, one thing that we had previously discussed is 0 is kind of an important spot for a sine function. So sine x over x, this thing goes to 1 when x goes to 0. So we're going to use this property. Now you might say, well, how do we get that from what we have? That's where some of this algebraic trickery comes in. So let's start with the function that we have, right? Tangent, first of all, we could rewrite that as sine over cosine. So let's do sine of 5x over cosine of 5x. And then, of course, we still have our sine of 6x in the denominator. And we're going, okay, well, how can I use this? Well, let's think about it. This original property is just talking about x, but of course, we could replace this. We could say, well, what happens if I say the sine of y over y as y goes to 0? Well, that's still going to be 1, right? This is just a variable. X is just a variable. We could switch it up. So then we could say something like, well, what if I let y be 5x, right? So let's let y equal 5x. So this would be like the sine of y on the top here. Well, what happens as x goes to 0, right? So if we apply this limit, x is going to 0, well, 5 times x should also go to 0, right? If x is going to 0, multiplying it by 5 isn't going to stop it from going to 0. i.e., that is, y goes to 0. So, hey, wait a minute. If I can pull in this extra y in the bottom, I can kind of make this work. I can sort of see where this would work. What's the long and short of this? What we're really saying is we can generalize this sine rule to something that looks like the following. Sine of kx, so just some generic constant k, sine of kx over k, if k goes to 0, right, that's going to be equal to 1. So we can, oops, sorry, x is going to 0, not k, my bad. X is going to 0. Right, so basically if I have sine of 5x, I would love to divide that by 5x. If I have sine of 6x, I would love to divide that by 6x. So that's exactly what we're going to do. We're going to pull those in, basically out of nowhere. It's going to seem like it's coming from nowhere, but we've done this kind of thing before. We can absolutely justify it. So x is going to 0. One thing you might want to do is split some of these pieces up. So for example, 1 over cosine of 6x. It turns out when we plug in 0 there, it's not going to be an issue. Times sine of 5x times 1 over sine of 6x. Now, I'm just doing this so that we can kind of see each of these pieces individually. But really, it's the same as what we started with. And what I want to pull in, and maybe I'll show this in a different color just so it's kind of clear that we didn't start with this, right? I definitely want to have this sine of 5x divided by 5x. But what that means is, right, I need a 5x in the bottom. Well, I can't just pull that out of nowhere. So I would have to pull in certainly a 5 and an x on the top. We also want this other piece. So we got sine of 6x in the denominator. Well, I kind of want to pull in a 6x in the top, because then I could use this property as well, and we'll kind of see why that is. But if I bring it in on the top, I got to bring it in on the bottom. So we're bringing in a whole bunch of extra stuff. You might say, okay, where's this all going here? So let's look at it. The limit as x goes to 0, 1 over cosine of 6x. Fine, we said that's not going to be a problem because this is 1 over cosine of 0, which is 1, so that'll go away. All right, here's the part where we start using that property. We're going to take the 5x on the bottom here. We're just going to move it over here, right? Of course, multiplication, division, you can move pieces around. It's no problem. The 6x on the top, we're going to bring that up above sine of 6x. And then what are we left with? Well, we still have a 5x. We still have a 6x on the bottom. And at this stage, you can certainly get rid of these extra x's, right? Those we don't need, so we can just get rid of those. All right, now a limit of a product means you can look at the individual limits. You can take the product of each of those individual limits. So basically we can say as x goes to 0, what happens to the first function? Well, that looks like 1 over cosine of 6 times 0, which is just 0, right? So it's going to be 1 over 1. So nothing really happens there. Times, well, we just said that the limit as x goes to 0 of kx, sine of kx over k, that's going to be 1. So the second part here, sine of 5x over 5x, that's going to go to 1. Turns out the limit as x goes to 0 of 6x over sine of 6x, that also goes to 1, because really what are we doing? We're taking the property that we have here, and we are just doing 1 over that, right? We're flipping the fraction. But if we do 1 over 1, hey, guess what? It's still 1. And then we finally have at the end 5/6. Okay, so we said that this guy, 1 over cosine of 0, is just going to go to 1. So we have 1 times 1 times 1 times 5/6. So guess what? This limit is 5/6. And we saw from our investigation that this looked like 0.833333, right? And sure enough, that is the decimal equivalent of 5/6. But really, we can leave it as a fraction here and say it just goes to 5/6. All right, so we had to be a little bit clever. We had to take a property that we know and manipulate it a little bit, but we were able to leverage that in our favor and really work our way through this kind of tricky problem here.